Jim everyone. So welcome to Algorand 101. Here we'll deep dive into what Algorand actually is and then also have an understanding at the end of the video how to write a smart contract and what a smart contract actually is. So before diving in, hi, I'm Dimanjan. I'm a full stack slash web3 developer and I've been into this space for a quite long. Have worked with multiple chains and have multiple hackathons down the line. And I love to ship products and teach folks about web3 and niche topics. So let's start. So what and why Algorand? So Algorand is a blockchain designed for speed, scalability and decentralization. So when I say Algorand is fast, I mean that it takes 3.7 seconds for transaction finality. What I mean by that is that when you send a transaction in a blockchain, in Algorand it takes 3.7 seconds to be included in the chain of blocks. You don't have to wait for 5 or 6 blocks for a transaction to be added in the chain like other blockchains, and it makes it more better for the scalable enterprises, right? Because it's time intensive. It's scalable because it can hold up to 6,000 transactions per second. It's decentralized and it uses pure proof of stake consensus. Okay, I'm gonna explain you how it works. So where in this consensus proof of stake consensus, the entire network participates in consensus protocol. We are aware of one of the famous proof of stake is delegated proof of stake. And only small amount or a group of people participates that allows it to be fast, right? But they sacrifice decentralization, right? Means attacker has accounts to attack and they can easily figure out who's gonna be the next validator, right? That really raises issues about security. But in Algorand, it uses multiple voting rounds. The group of nodes are selected randomly using VRF. Like even if someone have Algorand of Algo 5, they can even get selected, right? Everyone gets a chance as it's selected randomly. So yeah, too much jargons. No worries, I'll be your guide throughout the video and I'll guide you. And let's start from ground zero, right? Cool. So Algorand is a layer 1 blockchain. So let's start with Algorand standard assets, that is ASA. So on Algorand, if you want to create your own coin or your own token, you don't just need to write a ERC contract like other AVM. You just need to create a coin if you want to create a coin. Let's face by this. If you want to create a coin, you can create it by sending a simple asset creation transaction to the network. And that's it. You can create a coin. Yeah, it's inherent to protocol and those coins are called as ASA, Algorand as standard assets. It's easy to build a coin, a NFT or whatever assets you want to build. And then is atomic transfer. So what I mean by atomic transfer is that it can handle multiple transactions simultaneously. And that means if one of the transaction in the group fails, all the transaction in the group fails as well. Remember I said a transaction in a group, right? Okay, like Ethereum we have EVM. In Algorand we have our own virtual machine, that's Algorand virtual machine, that's AVM. It's fast, secure and low cost, right? We'll talk about it later in the slides. Let's talk about Algorand Stake Pro, that ASP. So let's break it down for you guys. Do you agree that the future is interoperability and there will be multiple blockchains that are going to survive and each blockchain serves their own purpose, right? But what if I can tell you that you can connect two blockchains without any bridges, any middleman? That means two blockchains can prove state on other blockchains with this ASP. Yeah, you are right. So why not write a ERC token? 20 standard like that. Let's say the answer. This is what the founder of Algorand said. Nothing can be more pernicious than premature standardization. Okay, what do I mean by this? When a field or technology or system that is still evolving, locking in into a specific standard too soon can limit innovation, right? It can prevent improvements and it can create long-term problems. So yeah, that's what it means. So yeah, as I told you that I'll cover this in the next slide. So now it's the time. Algorand virtual machine. So Teal. What is Teal? Teal is a low-level language that makes Algorand super fast. We also have 160 plus opcodes. There's 512 bits. That means it can handle large numbers. I also talked about atomic transaction in the previous slides. It has 3.7 seconds of transaction finality time, instant finality, and also has 6,000 transactions per second. And the gas fees here is 0.001 algo. That's really low. Now, let's talk about what current world scenario architecture looks like for a full stack app. We have a front end, we have a web server, and a database. Like for example, you can take about Netflix. We have a front end, a web server that brings your data from the database, talks you through APIs, and the data gets stored into database. Right. So how different the Algorand Web3 architecture is from our current Web2 scenario? It's nothing much. It's simple. Two things got extra added: Algorithm SDK, Algorand AVM, and a smart contract. I'll explain to you guys. So what a smart contract actually is? A smart contract is a program that lives on the blockchain that handles certain transactions based on certain conditions. It is executed, evaluated with Algorand virtual machine, and to interact and deploy a smart contract on Algorand blockchain, we use Algorand SDK either through frontend or web server. So in Algorand we have multiple SDK supports. There's SDK available on Python, Go, Rust, TypeScript. You can choose whatever language you prefer. So in Algorand we have two types of smart contracts. One is approval program and there's clear program. In approval program it consists most of the code logic and the code will be mostly present over here. In clear program it handles clear state app call. It lets wallet to forcefully opt out of the smart contracts, right? So for Python, if you're writing a smart contract on Algorand with Python, this is important thing to know for you. Python is a Python language binding for Algorand virtual machine that allows smart contracts to be written in Python, which compiles to Teal. Teal is a low-level language that makes Algorand super fast, right? This is a full architecture how it's done. It's compiled into PyTeal and it's compiled with a Gold CLI, and then it gets converted into a Teal bytecode that at the end get deployed as a smart contract in Algorand blockchain, right? Okay, so when you deploy a smart contract, it spits out one thing, that's ABI. So API is a standard that defines how to call your smart contract and how your data gets encoded, decoded, back and forth, contract integration, right? So through ABI, we can integrate our front end with a smart contract. And the ABI is a file of JSON methods that states how and what the contract does. So now let's code a bit. I have chosen TypeScript for me in this video. You can choose your preferred language and see you guys on the coding part. Yeah. So welcome to the coding part of this video. So let's start by creating a project. I have chose TypeScript for this. I'll locate in it. We'll just do the smart contract for today. Just name it Google contract. So you can name whatever you want. We'll create a basic detail build for user can starter. So let's first initialize and then I'll just explain what we are planning to build. No, for now. Cool. Okay, so this is how the folder looks like of an empty smart contract with a basic hello world. We write smart contracts in the format of we write the name and that we write .algo.ts. Okay. Let's create a folder. I'll call it 12 and let's write yes, cool. Right. So we are planning to build a simple detail wheel where a user can inherit their algo tokens for their loved ones, and their loved ones, for example, the recipient can claim it once the user is inactive or been died. A simple detail wheel, right? So let's start by coding for it bit. So how it start? Let's import contract. Okay. Also check how the contract is. Contract is basically a class, and when you write a contract over here, we have to extend the contract class, right? So let's start by writing our own. I'll write the contract. So let's export class simple will, and it uh, extends the contract class, right? You have to delete all of this. We don't need this. Okay, now what are the basic thing we need while creating a will? We need a owner, right? We need a beneficiary who's gonna claim the assets. We need the amount that's you're gonna deposit over there. That will be amount. That will be a number, right? And let's initialize it 0. You can also initialize a string with not values, right? Empty string. Cool. What else will be needing? Yeah, it shows the session. So yeah, it's active or not, right? Now the main thing, let's create a function, right, that will create a will. So let's write a function for that. It will have parameters. It will return a string. Yeah, okay, cool. So now what do you expect over here? Owner as a string, beneficiary as a string, and number, right? Is it enough? Yeah, cool. Now you have to do some type checks over here, and that's it. Like if not owner, not that, just wrote a certain create will function. I'll space it over here and make you understand how what it does and how it works. So good. Yeah. Right. So we have a private owner address, recipient address, and amount is active, like whether the user is active or not for a quit. And then we have create our will. It accepts parameters as the who's the owner, what is public address, who's the recipient, what's the willed amount then be stored, and it check if the owner exists, if the recipient is been correctly passed to the function or not, and you also check whether the will amount is less than 0 or not, because without 0 is a minimum value you should have, right? And this is active, right? I'll check it. So then we just initialize like we do in the classes, that this dot owner address is equal to owner, and then recipient address is recipient address, amount is equal to will amount, right? And this active is equal to true. And then we return the will is being created. This is the owner, this is the recipient, this is the amount. Same as the way, we'll also create a function that will help the user to claim the will, right? So what we'll be needing, right? Will be the function signature will be exactly the same. It will be a string. What is gonna accept? Right. This time we don't be needing the amount. We don't be needing the contract owner to be passed. What we need is the recipient. The recipient, that will be a string, right? Now how it will be done? You have to always check like if this is active or not. If this is active, we'll send error, right? So I've already wrote some of the smart contract over here on my second screen. I'll show you over here and then I'll explain you the flow. Okay. So if this is not active, then no active is found. Just check if it's this which is not active or not. If this recipient is not equal to recipient, then it will always store error. And if you then claimed, this will make sure that is active is false, that makes that the will is no longer available and it is claimed. Okay, so now what else function will be needing is that a check will function, right, to check whether the will accept or not. So a check will function is that, yep, I have kept the syntax very easy so that it will be beginner friendly. Check will doesn't accept anything as a parameter. It just checks whether this is the owner or not, and status. When you check will, it makes sure it changes the status as active, right? It has two. It is our ternary operator. This is active if it's active, else claimed if it's not active. And it again returns the will status, the owner, the recipient address, and the amount. And get will details that helps you to get the details of the will. It checks if not this owner, no will exist. If the owner exists, then this is the owner address, this is the recipient address, this is the amount, and this is active or not, right? This is the amount of algo that's been stored. That so hi, so I just debugged a bit about the last contract that I just showed you. The logic was all right. The only thing was this is here we don't support the throw statement like our normal TS file. So we have to return it like instead of throw new error we just make it return. And yeah, that's what the will does. I have explained you the flow. Here the user comes, the owner creates a will. Here we initialize the owner public address as owner, then we accept the recipient address, then the string as a will amount. Yeah, and then this also returns a string. It checks like whether the parameters are right or incorrect way. After checking whether the parameters are passed as right inputs, we again check whether the will amount is like equals to 0 or not, or there's no will amount passed to the function. And then if it's passed, we make sure that is being created over here. And then we have a claim will. The claim will, we have the recipient address and the expected recipient address, right? So we check over here that the recipient is exact the same recipient that the user has mentioned while claiming the will or not. And then we have check will. In check will, we check whether the owner, we check parameters as the owner, the recipient, and the amount, and is active, right? And check if the parameter if there is no owner, no recipient pass, no will be found obviously. And then if it's passed correctly, on checking the will, the status of is active is true, and if the will is not found, it's being set as claimed. This is a basic ternary operator that check whether is active because it is true. If not, then active. If it's true, it's active. If not, it's claimed, right? And then again we return it, and then we get the will details function. We takes owner as a parameter, recipient as a parameter, amount, and is active. Then again we check, and if there's no recipient, no owner, no will exists. And if it exists, we return them the things, right? As simple. We have created a basic, beginner-friendly will for the beginner user to know the syntax and can write. It's easy to write a smart contract in Algorand, right? If you're familiar with TypeScript, if you're familiar with Python, you can write on Python. If you're familiar with Go, you can write on Go. After that, we have to write a deploy config.ts. Okay, so I'll also explain this. So first we have to write a async function that's deploy. You can check over here, right? So after that, from environment we get the client, and then from environment it's deployer, right? After all the things said, a simple will factory. What is simple will? This is the thing. And then after writing the smart contract, what you have to do is you have to run npm run build, right? So you have to first cd into projects, right? And you have to cd into smart contracts. So well, yeah, what I have to do npm run build. Now you're gonna see it's gonna generate an ABI through it. That's it. All good. Everything is compiled. All is done. You can also see artifacts folder over here. Here we have will, and yeah, this client.ts. This all gets generated. Right. I'll show you one. Good. Yeah, you can see it. This is what the API looks like. This make sure what is done, how it is done. You can see the function name over here is name. Claim, the arguments are string, recipient, and there's another function, there's a string, expected recipient, it returns a string type. It was ABI does. It explains what the function does, how a smart contract is integrated, and all. After this client is generated, this simple will client.ts, we need this, right? Over here you can check I've imported it above this, and then you test it. If us make const owner deploy dot address, the one who's deploying, then a recipient address, you may add certain amount of algo, and then create app dot send dot create will. What is the create will? Create will is this function that we created. Then we do create will, and then you pass the arguments. The arguments are listed over here. You can check over here. Right, I'm showing you. Claimel, this is the claimel. Then here will be the create will. Recipient. Yeah, this is the create will. The function name. This is the argument that they want is a string of name owner, string of name recipient, string will amount. Exactly the same thing we're passing over here, right? Where's one? Yeah. Owner, recipient, will amount. Yeah. Console log it. It's done. Then we check response. Then we again do is same thing. Check will. Check will is again a function you can check over here. Let me show you where the check will is. Create yeah, this is a check will. This is the argument that the ones. Exactly pass the same arguments over here. It's so easy. Exactly same way we does the same for this, and then write our deploy.config.ts. And currently I'm not locally running it, so we will see the error. I will show you the error that we will see over here. Implement deploy well. There's an error, right? This, get it? So what I'm not doing is I'm not running the local function on my here. It will get, that's why I'm getting this error. Once I run this and deploy, it'll all good. Yeah, and that's the whole thing. Now you know how Algorand works, how Algorand is different from other blockchain, and you also got to know how to write our own smart contract. And it's simple easy how to write our own smart contract. You also look for what's API, also see saw how to integrate a smart contract, and also test them with deploy.config.ts. Yeah, and that's it. Stay tuned, and that's all. Thanks for watching.